Good afternoon, everybody. I want to present to you the work we did here in Benin and the work we plan to do in the length of our topic, from field survey on Boyam quality characteristic to key priority analyze at lab level. In our understanding, it is how to measure or translate quality characteristic to lab analyze. In our general approach, we collected quality characteristic from survey, and we check off some probable lab analysis that can be used to measure, to translate those quality characteristics. And in the last time, we do sensory analysis to measure to establish relation between sensory quality attribute and lab analyzer we have already selected. Our expectation is firstly to reduce the number of quality. Initially, we have 16 quality characteristic. If in the final, with the relation between within those characteristics, we can reduce them to 6 or 5. That is the best. And in the other hand, we want to also check the link between instrumental or lab parameters, and to check with the relation between sensory analyze, to check the relation, and select the key priority lab analyzer that will be used in the future. The quality characteristic of Boeing Yam we collect from survey and processing dances were grouped in two categories, in two main categories. The first is sensory characteristic, high and poor, and the second is the emotion characteristic. What we did, we have two kind of data from to build these two groups. We have a common quality characteristic that we get from all study, all activities, and we have static quality characteristics cited by more than 10% in the case of field survey, and more than 15% respondents in the case of processing dances. In the methodology, only the sensory characteristics were addressed for lab analysis. Concerning the raw material quality, they are grouped as other people show it. They are grouped in high quality and poor quality. Related to high quality, we have smooth skin, thin skin, khaki skin, thin line on the skin, wide head and pointed head. And for poor quality, we have the presence of rootlet in flesh, flat tuber, and rough skin. For now, we don't learn in the literature any available method to measure those characteristics. So we have to check the method in this way for the raw material. As far as the quality characteristic of yam during processing into Boyan is concerning, the expected lab analysis, the probable lab analysis we check in the literature shown in this slide. For the peeling ability, we have the easy to peel, we have a sticky substance, stability of color, change of color. The expected analyzer, we have For stick, for easier filling, we don't find anyone. For sticky substance mucilage, we thought of starch, amylases, and polysaccharides. For stability of white color and yellow color, change of color, we thought of lab colorimeter and total phenol. For viscose boiling hot water and fluid boiling water, we are thinking about starch, amylose, and consistometer to measure those parameters. And for easy to break with a fork during cooking, we find for tester analyzer essentially penetration tests. For the quality of boiled yam and the expected analyze for assessing them, we have a yellow, white color, dark brown, that is the same. It is a colorimeter and total phenol. For the tester, we have tester in hand, we have tester in mouth. Those testers are disaggregated in sticky to the finger, hard to break, easy to chew, crumbly, and so on. We think about penetration test, TPA, starch, amylose, pectin, cell wall, fiber, and swell per power. And for taste and aftertaste, for sweet taste, we find about HPAC, sugar, and for bitter taste and bitter aftertaste, we think about polyphenol and glycoalkaloid. So after establishing those quality characteristic and identify some lab analyzer that can be used, we calibrate those attributes during sensory analysis to versus lab analysis to evidence key priority analysis. What we can note here, we saw during the generation of quality attribute during sensory analysis that quality characteristic we have seen during survey were consolidated because we saw another over quality attributes, which is additional to the quality characteristics we already listed. So during this sensory analysis, it is a kind of calibration with lab analysis. What I will show here is only an example, some example related to tester tester attributes. And when we take this example, we correlate, we did the sensory analysis together in parallel with some lab analysis, dry matter, content penetration tests, and TPA, and so on. The first thing we have shown is the correlation within quality attribute, and then the correlation within lab parameter, and then the correlation between quality attribute and lab parameter. Those for the first correlation between. Do you see? I don't know why you have. Yes. Okay. For the first correlation between between quality attribute within quality attributes, it is only to reduce the number of attributes. So when we did, I give some example of tester. We saw that easy to chew were negatively correlated to hard to break, and crumbly also were negatively correlated with hard to break. So if we take attributes such as crumbly, hard to break, and the easy to chew, we can choose only one of them to represent this group. In addition, we saw the correlation between white color, sweet, and crumbly, between bitter, aftertaste, and black dot. We have to choose one of them to represent the group. And so in the last time, we can build the reduced list of quality attributes. From the 16 we have, we can come to 7 or so. That is what we did. This is an example of a tester. We have the same for other parameters. This concerning the lab parameters and related only to test measurements, we saw that dry matter and gumminess and dry matter and chewiness were correlated. So from those parameters, those measurements, we can choose one of them to represent the group. Here in the right hand, we don't see any significant linear correlation between dry matter and hardness. We expected, but we cannot see it. We will try again to see if we can identify other relation between dry matter and hardness. So that is the way we reduce the number of analyses and the number of quality attributes. Now, when we cross sensory quality versus lab analysis to select the key priority robust analysis, we saw some of parameters instrumental or biophysical parameters are correlated with sensory attributes. I gave here some cases. We have dry matter, which is correlated with sticky. We have it here. We have a hardness, instrumental hardness, I say, and the work energy exists to penetrate the sample, which is correlated with hard to break. So from this, we can say when we saw the correlation between hardness and hard to break, and then to the energy the work to exert with hard to break, I think that penetrometer test is a good tool, a good instrumental method we can use. So we did the same on the other parameter related to the biophysical analysis. That is globally what we did. On the feature, as I said, on the raw material, we don't have much method or any method to translate the quality attribute into instrumental or biophysical analysis. On Boeing, we have some biophysical and chemical analysis to complete instead of getting all of the relation between the sensory analysis and the parameter, biophysical parameter. At the last, when we will do all of those analyses and all correlation, we can select the list of key priority robust analysis for lab. That is the general approach we use here. I think I'm in time. I say thank you for you. That is what I can present to you. Thank you very much.
Thank you, Noel. Thank you very much for this very clear presentation on your preliminary results, which shows very well the importance of taking into consideration bad or undesirable quality attributes together with good ones, and not only to focus on measuring good or desirable attributes. And thanks also for explaining your methodology and for taking time to provide the different precisions on your procedure and how you correlate traits. You try to make correlations between traits to reduce the number of analyses to be performed at lab level, because choices need to be made. Definitely, we need to reduce the number of analyses we will perform. So thanks a lot. And I am now giving the floor to the audience for questions, for clarifications. So if you have a question, you can write it in the box, in the chat box, or raise your hand using the small, the blue hand in the toolbox. Thanks, Noel. So,
thank you. Okay.
No questions for Noel? People who are working on yam in Nigeria, do you have questions for the Benin team? Okay, I see one question in the box from Deborah Rabin. Could you tell us a bit more about the survey sample that led you to choose these characteristics? The survey sample that led you to choose these characteristics. How did you choose quality characteristics?
Survey samples.
The sampling, yes.
Yes. I think in the methodology of activity 4, we have to select seeds, yam varieties, and we have to do the sensory analysis on those samples. That is the guides of the methodology Genevieve and Laura provide to us to do this work. I don't know if you understand what I mean.
I mean, yes, I think we understand that you have been following the methodology that has been developed partly within RTB Foods and with other methodologies developed before. So it is an approach in several steps, and you have been including processors, but also consumers of boiled yam together. And we've been following a process in three steps. So I think this document, well, this methodology has now been published as part of the special issue dedicated to RTD food products that everybody or most people contribute to recently. And there is now a paper dedicated to this approach adopted in RTB foods and adapted in RTB foods. So Deborah, I think you can get in touch with Laura from Web Package Once. She's the first author of this methodology. And Geneviève is the last author. So you can get in touch with her, with them directly. You'll get to the methodology paper. I see a question from Busi. Busi, you can ask your question to Noel.
Yeah, thanks, Eglantine. Noel, thank you for the enlightening presentation.
Thank you very much.
Yeah, on the slide, on the characteristics of the raw yam.
Yes.
Yes, could you please clarify, because under high quality, yes, this one, under high quality, you have cracked skin.
Mm-hmm.
Yes.
Yes. What that means? It is when you have the skin with a kind of straight, not line, but ça de fendille. Comment on dit ça? C'est fendillé.
It's cracking.
Yes, I think, yeah, cracking. Cracking.
Fendillé.
Yes,
Yes.
cracking.
Yes. What? That is the words. The skin of the raw material have some of a kind of line in the profondeur. Comment on dit ça?
The depth.
Yes, in the depth. Yes,
Depth.
yes. That is what I mean.
Okay, because my interpretation is when something is cracked, that means it's slightly opened, which then will be an avenue for insects to enter and destroy the yam. So I have this conflict of then how can it be a high quality if it's open and it will allow insects to attack the yam, and we know yam is stored.
Yes, I understand what you mean. But they're seated as a good, high quality. When they have, I don't know the level of the depth, but a little bit the depth or more depth, I don't know. But the seated, cracky the skin as good quality for boiling yam.
Noel, it's DJ. Maybe it's because when you have when the skin is not so smooth, it's more difficult to peel. Maybe it's because of that.
I don't know.
Thank you. Another question from Suzanne. Suzanne is asking whether the genotypes in these studies, in your analysis, for example, I guess is used during surveys, do they represent the entire range of genotypes in breeding programs, the diversity that we have in breeding programs?
Yes, I think because we choose 6 yam variety, the variety with belong to the high quality variety and the bad quality variety and the middle quality yam variety for boy yam. So they can represent a range of variety that can be grown in the area for farmers. We have good variety, medium, and bad variety. So we cover the range all the range of the quality of yam variety.
Okay, and how did you select the bad ones? Where do they?
It is from the study 3 and 4. They cited that it is a bad variety, essentially from the study 3.
Okay.
Because we have a question that asks for the bad variety, the high quality variety, and the medium variety. So we select from this activity, those varieties.
Okay, so there's another question just linked to this one and to your answer, Noel, from Benjamin Okoye from Nigeria. He's asking, is these results coming from activity 3 and 4 and activity 5 or only activity 3?
From activity 3, activity 4 is during the processing. Activity 4 and the activity 5. And also, we complete it during the sensory analysis. When we generate quality attribute, we find over attribute that we add to quality characteristics we already established.
Okay, so actually your team is one of the most advanced ones because you have already analyzed results from activity 3, 4, and 5 from work package 1, and you have already established correlations between sensory results and lab analysis. And
but we haven't finished. It remains more to do.
Sure.
That biophysical analysis, we have some to do before finish the correlation we want to establish.
Of course, but your presentation shows very well the pathway that we have to follow to go from survey results to correlations and lab analysis to understand the drivers of quality. Is there another question from the group for Noël? Okay, Busi, you have another question for Noël?
Yes, maybe I throw it to the group. Is correlation of 0.5 to 0.7 good enough to conclude?
I don't understand very well. Repeat the question, please. You say?
I'm asking the group, Noël.
Yes.
Yes, if a correlation of 0.5 or 0.7 is good enough for us to conclude.
No. There is a significant, but we wait before conclude it. I can say that it is good to conclude because we want some robust lab analyzer to do. If we take only into account the significance of the correlation is not the best way. We have to take into account the correlation and the variability, the variance explained by the parameters before concludes. So 1.5, I can say that it is good to take this lab analyzer as a robust analysis. We will present what we obtain. I cannot give you now a list of analyzers we want to do. So we to do over analysis, and we will see the best one, the robust, to take into account to continue. Thank you.
Thank you, Noël.
Okay.
Another question from the audience? Oluyinka, you have a question, or is it just an applause for Noël? So I think, yes.
Please.
Yes, yes,
Boni.
Dr. Boni.
Hello.
Hello.
For all of you. Thank you for the presentation of Noël.
Yes.
I would like to know if it is possible to send us this presentation through our
Yes,
email.
I think Eglantine will do it.
Yes, actually, first I am recording the presentation, and I am uploading the recording plus the PDF file of the presentation on our Slack platform. Have you linked to our Slack platform, Dr. Boni?
Yeah, I think.
Okay. Each time I am sending a message with the link to the Slack platform. So you will find in the webinar channel, all recordings are there. plus PDF files of the presentation. And if you really want to have the PowerPoint file in the PowerPoint version, you can directly write to Noël, and he will be sending you if he accepts.
Thank you. Okay. Thank you.
Okay, thanks everybody. I think it's time to close our mini webinar. Thanks very much, Noël, for this very good presentation. I think it opened the pathway for improvements for everybody to see where we go to, actually. And the boiled jam is a really good example.
Okay.
What's RTB food approach, and what we should be doing in RTB foods. So thanks a lot, everybody, and we meet in 2 weeks for our last webinar before summer leaves of PMU. And then in 2 weeks, we will have a presentation from somebody from IIT Cameroon, and he's a PhD who will present his approach and his methodology he wants to put in place to assess the impact of the institutional organization and on the adoption of new cassava varieties in Cameroon. So thanks a lot, and see you in 2 weeks' time.